All right, 5.1, day number 1 on antiderivatives. So anti-differentiation undoes or reverses the process of differentiation. It's the inverse function of differentiation. So given that f of x, we look for an antiderivative, capital F of x, whose derivative is f of x. So you'll see here the notation. Right, the derivative of big F of x equals f of x, or capital F prime of x equals f of x. So for example, something whose derivative is x would be x squared over 2. Another function, x squared, would be x cubed over 3. X cubed would be x to the 4th over 4. And x to the n would be x to the n plus 1 over n plus 1. However, we add a little something onto the end because we know that since a constant has a derivative of 0, that any one of these new functions, capital F, in any of these cases could have some kind of constant attached to the end. Therefore, we have to account for that. Now, how could I check to see if I found the right antiderivative? Well, I could take the derivative. All right, so the derivative of this one, f prime of x, would be 2 times x to the first power over 2, which would then equal x. So I've confirmed using differentiation that I picked the correct antiderivative. So here you can see this idea of plus c, right? So the family of antiderivatives, let f be any antiderivative of little f on an interval I, then all the antiderivatives of f on I have the form capital F plus c, where c is some arbitrary constant. You can see the slope at any point on any one of these curves, right, is going to be equal for every x value. Therefore, we have to throw in that arbitrary constant at the end. So let's try a couple. We'll add double lightsabers going again. Alright, so here we're going to throw a constant out in front and kind of distract you a little bit, as well as a couple of sneaky ones here. So f prime, or capital F of x. Well, what I would do is I would add 1 to the exponent, divide by that 1, and leave the number that was out in front. So what would f prime of x equal? Well, that would be 9x squared over 3, which, go figure, reduces down to 3x squared. Well, we can't forget plus c. I almost did it myself. Okay, here, this one, part B, you're going to think about way too much. But capital F, I know, is inverse tangent of x, or arctangent of x plus some constant. Okay, sine of x, well, f in this case would have to be negative cosine of x. And secant squared, again, identifying and remembering that the derivative of tangent x gives you secant squared. So notation, we know that d dx of f means find the derivative of f with respect to x. We need a notation, right, a short notation that tells us quickly find the antiderivative of f. So f of x is equal to, this symbol right here is called the indefinite integral. That right there is the indefinite integral. So this tells us, right, this tells us to take the integral of f of x with respect to x. All right, and that gives us this answer, big F of x, which is our antiderivative. So we can write example 2, which we just did above, right, a, b, c, and d. We could write each of these like this. So like I said, this would be, what would this be? X to the third, 3x to the third over 3, right? Or, right, we could just write that as x cubed plus c. This was arctangent of x plus c. this was negative cosine of x plus c, and this one was tangent of x plus c. All right, this notation is what this is all about. All right, this tells you to find the antiderivative, oh, we forgot a dx there, of each of those functions. All right, rules for integration. All right, in general, when you see some kind of power function, like x to the p, always add 1 to the exponent and divide by that thing. Okay, that's going to be your power rule of indefinite integrals. Okay, the constant rule, what I would do is, to make things simple, I would pull that constant out in front and then just find your antiderivative of f of x. And don't forget plus c on the end. All right, the sum rule, again, if you got two complicated functions, what you can do is you can just split them up and use the sum rule. So you could take the antiderivative of f of x with respect to x and the antiderivative of g of x with respect to x. And don't forget your constant on the end when you're done. So let's use example 4. I'm just going to use a simple notation. I'm not going to use, well, I guess I can model the sum rule. What I would do here, though, is I would actually pull out that negative in the 10x. Okay, actually, you know what? I'll do even further. Scratch what I just did. I'm going to do a little bit of a constant rule as well as a sum rule. Alright, and in the process, I think it'll show you some shortcuts and potentially make things easier for you in the long run. So this would be 3 times x cubed over 3. Right, this would be negative 10 times x squared over 2. Notice I'm not writing plus c yet. You'll see why in a second. This would be 7x. I'm going to throw c in on the end, because if I had 3 c's, it'd just be another constant anyways. So it looks like I'll get x cubed. These 3's will cancel. Looks like the 10 and the 2 will cancel, make that a 5. So that would be negative 5x squared. And then here I'd get negative 7x plus some value. Right? So big F of x, the antiderivative, would be that. Okay, part B. I'm going to rewrite f of x real quick as x to the negative third plus 6x to the negative 7th. And then when I write out my integral, right, if I want to integrate this, I would have x to the negative third dx plus, I'm going to pull out that 6 and have x to the negative 7th dx. So this, be careful now, we're going to add 1 to the exponent and divide by the original exponent. I'm going to leave the 6 out here. And I will have for my antiderivative x to the negative 6th over negative 7. Oops. I don't need that negative. I already put it out in front there. And plus c. Therefore, my antiderivative would be, looks like negative 1 over 3x squared minus 6 over 7x to the 6th plus c. There is our antiderivative. All right, let's keep going. A couple more. I'm going to split these up. So I'm going to write f of x as, let's go, ooh, this is going to be good, 4x plus 3 minus 8x to the negative 5th. Let's see if you can get yourself there. All I did was divide each of the individual terms by the denominator. So I'm going to take the integral of 4 times the integral of x dx plus 3 times the integral of 1 dx minus 8 times the integral of x to the negative 5th dx. I'm going to pause. You can pause as well. I'll come back with some work. Alright, so there you have it. I just did the integral of x, which is x squared over 2, multiplied by 4, reduce that to 2x squared. Integral of 1 dx is x, 3 times that is 3x. Notice the two negatives here will cancel to make that positive 8 over 5x to the fourth, and then plus c on the end. Alright, let's look at one more before the end of this lesson, or two more I guess. What I would do here is I would FOIL, and what that will look like will be y to the fourth. Okay, so what I'm doing is y squared plus 4y times y squared plus 4y. Okay, so I get y to the fourth plus, looks like 8y to the third plus 16y squared dy. And you can integrate with respect to y, that's totally fine. I'm going to kind of do this one, I guess I will do it, split it up, y to the fourth plus 8 integral of y to the third dy plus 16 times the integral of y squared dy, and we'll come up with big F of x. Alright, so this would be y to the fifth over 5. I would get, in this case, y to the fourth over 4 times 8, which would be 2y to the fourth. And then I get y to the third over 3 times 16, which would be 16y to the third over 3 plus c. Alright, last one. I'm going to pull 3 out, take the integral of x to the 2/3 dx. Okay, so that'll be 3 times the integral. I'm going to, again, add 1. So I get, let's see here, x to the 5/3 over 3/5. Okay, plus c. Let's do a little work on that. That would be the same as 3 times 5x to the 5/3 over 3, which would give me big F of x. That's supposed to be an arrow. Good job. There we go. The 3's would cancel, and I'd get 5x to the 5/3. Now I'm not real certain that that's correct. I don't know. Maybe I screwed up some algebra. Let's try it. Let's do f prime just to confirm. I would get 5/3 times 5. Yeah, I think I did something wrong here. X to the 2/3. Yep, I did something wrong. Okay, this should have been 5/3, which would have made this 3/5. Is that right? I think so. Yep, which would have made this 9. Let's see now. That would have made this 3 times 3, which is 9/5, which would have made this 9. Oops, I'm sorry. Which would have required us to then, well, looks like I just got to scratch that out, huh? Okay, scratch that. So I believe this is the correct answer. Big F should be 9x to the 5/3 over 5 plus c. Let's see if that's right. So big F prime would be, bring this down, multiply by 9/5 x to the now 2/3. Okay, it looks like the 5's cancel and the 3's reduce, and there we have it. Alright, excellent. So this is our answer. I had messed that up, my apologies. But that is 5.1, day number 1 on antiderivatives.